So far we learned about the intersecting lines and non-intersecting lines, right? Now let's talk about the parallel line. We know about this transversal, right? You have two parallel lines and this line is called as the transversal. We know that very well. So we are going to discuss what are the combination of angles which are equal, if they have any kind of relation between them, that we are going to learn. It's very important. These 4 or 5 types of property that we are going to learn related to parallel lines and its transversal, it's very helpful that you are going to use in the chapter of triangles, after quadrilaterals as well, and areas and these circles as well, right? So this is the very important concept. Pay attention well. So let's start. Corresponding angles. I hope that you must have learned the name of this already in previous grades, right? Let's repeat one more time. Okay, so first, corresponding angles. Let's start with the corresponding angle. What I'm going to do, I'm going to give the name to the angle first of all. That's very important. So 3 and 4, then 5 and 6 here, 7 and finally 8, right? So we have total 8 angles when we have 2 parallel lines. Done? Now let's talk about the corresponding angles. Corresponding angles means what? See, let me give you a very simple hint, right? Corresponding angles means F. Wherever you can see the F, that is the corresponding angle. Okay, so how? Let's see in the alphabet of F. That is, see, this is one angle and another is this angle. That is the corresponding angle. So these two angles are equal. Corresponding angles are equal. So here, if we see, first of all, let's identify the F itself, right? So this is one F, right? This is one F. So which two angles are there in this part? See, compare with this F over here. So that is angle 4 and angle 8. So we can write angle 4 is equal to angle 8. Very simple, right? Now you can twist and turn or flip or upside down this F as well, right? So if we do reverse of this F, it will look something like this. So this is the one angle over here and this is the another angle over here. So let's draw that F as well. So here is that second F. Now which are two angles? Here it is angle 3, very good, and here it is angle 7. So we can write angle 3 is equal to angle 7. Now let's turn it upside down. So what I mean by upside down is, let's say this one, right? So this will look something like this, right? Still it is F. Now remember, these are the two angles, right? So this is the F here. See, this is the F. So this angle and this angle. So what is the name? Angle 5 and angle 1. So angle 5 is equal to angle 1 is equal. Now let's flip it. So if we flip it, it will look something like this. So this is the angle and here it is. Now let's try to find F over here. Yes, it is here, right? This and this. So here it is angle 6 and here it is angle 2. So angle 6 is equal to angle 2. Very simple it is. So there are 4 pairs of corresponding angles, and remember, corresponding angles are always equal. Remember, they are always equal, right? So angle 1 with angle 5, then angle 4 with angle 8, angle 2 with angle 6, angle 3 with angle 7. Now don't mug up the numbers. Many students do that. Always avoid doing that. The reason behind that, these numbers are not going to stay in the same position, and that's very hard thing to mug up the numbers, right, at some point. So better you understand the alphabets, right? If you find the F anywhere, remember these two angles will be equal. I told you there are 4 positions of the F, right? The normal one, then you flip it, then upside down. So there are 4 pair of corresponding angles in the transversal, right? So this is about the corresponding angle. Now let's discuss about the next one, that is alternate interior angle. Now we know this, it is of Z type. So let's identify how many Z we can have over here. So first is this one, let's see. Okay, first let's name it, that's important. So 1 and 2, then 3, and finally 4. Then let's write here 5, then 6, here 7 and 8. Obviously 8 angle like the previous case. Let's start with the Z. So first Z, that looks something like this, right? So you can see that which are the 2 angles. These 2 angles we are interested in the Z. See here properly, right? So this is what we are interested in. So here there is one angle 3 and angle 5. So angle 3 is equal to angle 5, right? Now one more Z, let's flip it. It will look something like this. So this 2 angle we are interested in. So this is the another one, right? This is the Z. So here angle 4 and angle 6. Angle 4 is equal to angle 6. That's it. Now remember one thing, there are 2 types of alternate angles. Either you have interior or exterior. Now interior means what? Which is between 2 parallel lines. Always remember that. Interior part of transversal means between the 2 parallels. And exterior part is which is above this parallel line and below this parallel line. Remember that. So this is about the alternate interior angles. Remember, it should be forming Z. Sometimes if you have the transversal like the standing one, then you can form N as well, right? Let me just show you. So let's take an transversal like this, and you have this, right? So see, in this case, this is what your Z is about. It looks like N here, right? So it is possible. Remember, it depends on the question you have it. Generally, if you have the horizontal parallel lines, then you can start with the Z. If you have vertical parallel lines, then you will be forming the N or flip of it, right? So this is about the 2 very important cases. So first is corresponding angles. Remember the F, right? If you form the F, then you will be getting 2 angles that will be equal. And alternate interior angle, AIA also you can call it, right? So that forms Z. There are 2 Z's which is in the interior part of the parallel lines. So these are the first 2 cases. Let's discuss other cases. Now let's discuss other 2 cases which is very important as previous one. So first let's start with interior angles on same side, IASS. So first of all, let's start with the names. Angle 1, then 2, here 3 and 4, then 5, 6, 7 and 8. Okay, so we are talking about interior angles, right? So I told you interior angle means what? Which is between the parallel lines. So we are going to talk about only angle 3, 4 and 6, 5. Okay, interior being done, and we only need to talk about angles on same side, right? So we are talking about the angle 3, 4, 6, 5. Now same side means they should be on the one side only, not the another one. So we are going to talk about 3 and 6 and 4 and 5. So what is the relation? Okay, 3 and 6, they doesn't look like same, right? Because this is obtuse angle and this is acute angle, right? So there is a relation that if we add those angles, we get 180 degree. So we can write angle 3 plus angle 6 is equal to 180 degree. 3 plus 6, if you add them up, you are going to get 180 degree. Same goes over here as well. That angle 4 and 5, angle 4 plus angle 5 is equal to 180 degree. If you want to remember this, you can remember with the alphabet C over here. You need to take two angles which is inside the C and add them, so you get 180 degree. Very simple concept it is. IASS, interior angle on same side. You add those angle and you get the answer as 180 degree. Very simple, right? Let's discuss the another last case, alternate exterior angle. Let's start with the numbering. So 1, then 2 here, 3 and 4, 5, 6, 7 and 8. Now alternate exterior angle. So this was the case of the interior angle. This is about the exterior angle. So we are not going to talk about the angles which is inside this parallel line. We are only going to talk about the angles which is outside of it. So 1 and 2, 8 and 7, right? So that is the case about the exterior angle. Now we need to alternate it, right? So if you take one on this side, you need to take another on this side. So first of all, understand that we are going to talk about this 4 angles only, exterior. If you take one over here, you will be taking what? Angle 7. So let's write angle 1 is equal to angle 7, right? Now if you take 2 over here, now which we will take over this side, that is angle 8, and next we can write which is angle 2 is equal to angle 8. Very simple it is, right? So alternate interior angles was about the inside two parallel lines, between two parallel lines, not actually inside, between two parallel lines, and exterior outside of the two parallel line, right? So upper part and the below. As we talk about alternate, if you take 1 over here, take 7 there, 2 over here, 8 here. So these are the 4 most important type of property that we need to learn related to parallel lines and the transversal. So let's recap it. First we learn about the corresponding angles. So corresponding angles, right? Corresponding angles, it's all about making F, right? You need to make F, maybe flip or maybe invert it, right? Next was about alternate interior angles. You make Z, right? Same normal one or flip one, and can also work out in the case of standing parallel lines, right? So these are the shapes for AIA. Next we learn about the interior angle on same side. So it's all about making C, right? Two angles inside the C. And next we learn about the alternate exterior angle, last one, AXA, right? So we take the exterior angle, right? And remember we take the alternate as well. In this case, corresponding angles are equal. AIA is also equal. IASS, they add up to 180 degree, and AXA, that is also equal. So this is the case about the parallel line and the transversal. Now let's solve few questions related to that. So far we discussed about the transversal and parallel lines. Now let's start the sums related to that. We have the figure in the question. Let's read the question and solve it. In the given figure, M parallel to N. So it is given this line parallel M. This line M is parallel to line N, right? Two lines are parallel. Then determine all the angles. So we have the relation between these two angles, angle 1 and angle 2, in the form of ratio 4 by 5. Then we need to find all the remaining angles here. So let's start. How shall we approach? First of all, let's write the given condition. We have here angle 1 by angle 2, that is equal to, right? We can write 5 by 4, right? Angle 1 by angle 2 is equal to 5 by 4. So in this case, I told you already that what we are supposed to take, we will take angle 1 is equal to 5x and angle 2 is equal to 4x, right? Remember that whenever ratio is given, take the product of x, then we can get the value of two angles. Now angle 1 and angle 2, what relation can we apply over here, right? You need to use all the knowledge that you learn about this parallel line so far, about the complementary, supplementary, linear pair, vertically opposite angle, corresponding angles, AIA, AXA, IASS, right? Every knowledge, every kind of theorem you can use over here. So let's start. So angle 2 and angle 1, I can say it is the linear pair. So let's write linear pair. Linear pair. Always mention the condition that you are applying, right? Now linear pair add up to 180 degrees. So let's write angle 1 plus angle 2 is equal to 180. So we can write here that 5x plus 4x is equal to 180. Now 5 plus 4, that is 9x, is equal to 180 degree. So x is equal to 180 degree over 9, that is 9 ones are, and here 20 is up. So value of x is 20 degree. That being done, now we need the value of angle 1 and 2. So we can substitute over here that 5 into 20 will give you 100 degree, and here 4 into 20 will give you 80 degree, right? So we have this angle is equal to 100 degree and this angle is equal to 80 degree. Very simple, right? Now we need to find the remaining angles as well. Before we move on to these 4 angles, let's find the value of angle 3 and angle 4, right? That's very easy. What kind of pair of angle it is? See, it is vertically opposite angle, right? It forms x, right? Opposite of 2 is 4, opposite of 1 is 3. So let's write vertically opposite angle. Vertically opposite angles. So what we can write, angle 4 is equal to angle 2 is equal to, what's the value of angle 2 over here? See, that is 80 degree. And next I can write angle 3 is equal to angle 1. So angle 3 is equal to angle 1 is equal to 100 degree. Then very simple, we get this value as 80 degree and this value as 100 degree. Very simple. So far we find the 4 angles. We still need to find the remaining 4. Now how can we get the value of all these 4 angles just by one theorem? Try to reduce the step, right? You can solve this sum by applying so many theorems as well. It is possible, linear pair, vertically opposite angle, then you can use AIA, then you can use AXA as well. But I want to do the minimum number of steps, right? I'm doing my best. Now see, I tell you, we can make F over here. F means what? Corresponding angles, right? F means corresponding angles. So this is the one angle over here, this is the another angle over here. So let's write corresponding angles. Corresponding angles. Now whatever F you can make it, you will be able to get all the angles. Remember, angle 1 goes with angle 5. So let's write here that angle 5 is equal to angle 1 is equal to 100 degree. First angle is done. Now angle 2 goes with angle 6. So let's write here that angle 6 is equal to angle 2 is equal to 80 degree. Now similarly, this angle 3 goes with angle 7. Very simple it is, right? Angle 7 is equal to angle 3. Angle 3 value is what? 100 degree. And the last one, angle 4, will be equal to angle 8. So let's write angle 8 is equal to angle 4 is equal to what? 80 degree, right? So now we have the value of all the 8 angles, 1 to 8, right? You can even mention in the figure. The advantage of writing the value in the figure is that you can easily see over here, right? If this is 100, opposite will be 100. this is 80, opposite will be 80, right? Corresponding 100, so this 5 will be 100, 2, so 6 will be 100, 3, so 7 will be 100 as well, 6 will be 80, 3 will be 100, so 7 as well, and 4 and 8, that is 80. So this is how we do it. Let's recall this step. Ratio means what? We multiply by the x, so 5x and 4x. 1 and 2, we know it is the linear pair, so add them and we get 180. Get the value of x, substitute the value of x again in the assumption, so we get the value of angle 1 and angle 2, that is 180 degree respectively. Afterwards, we use vertically opposite angles. Vertically opposite angles means what? Opposite of 1 is 3, opposite of 2 is 4. So we get the value of angle 3 and 4. Now, afterwards, we wanted to get all the 4 angle in the one go. That is corresponding angles. So 5 is equal to 1, 6 and 2, 7 and 3, 8 and 4. So this is how we find the missing angle in the transversal. Let's discuss next question. Let's do one interesting question though. Let's start. In the figure, P parallel Q. Line P is parallel Q. This is very important condition, right? If lines are parallel, then only we can apply the different kind of angles that we learn. What is the value of B? We need to find the value of B over here. Very less information is given over here. Though let's try. Here we have this angle B, this angle 1 by 2A, and here it is A. So how shall we approach this, right? Very interesting question it is. Remember, your final answer will be in the form of numbers. It will be in the form of numbers, not any random one. So first of all, let's start. First of all, name the angles, right? We need to have some name for the angles. So let's start this angle. Let's say over here 1, here 2, then 3 and 4, right? Let's say this angle 5, this 6, here 7 and 8. Then naming of the angle is done. Now how shall we do it? Now whenever this kind of questions are given, that there are most of the quantities are missing, in that case try to have all this unknown angle at the one point only, at the one vertex only. What I want to say, see, we at this vertex we have B unknown, 1 by 2A unknown, right? And here another vertex we have A as the unknown. Can we shift this A into this vertex? Try to think which property of the angles will be helpful to us, right? What I want is this A angle to come over here. Now if it wants to come over here, which number it will replace? That's the question, right? See, this is a kind of F, right? This is F, so this angle over here and this angle over here is equal. So what kind of angle it is? Corresponding angle, right? So let's write corresponding angles. Corresponding angles. So what we can write? Angle 4 is equal to A, right? So let's write here angle A. Now see, angle 1 and angle 4. What kind of pair is it? It is linear pair because P is a straight line. It is given over here. So let's write linear pair. Linear pair. For the linear pair, addition will be what? 180. So let's write 1 by 2A plus A is equal to 180 degree. I get the value of A. If I solve this, because this is linear equation in one variable, A over here and A over here as well. Let's take an LCM, or you can do one thing, multiply everything by 2. That will also work out. Just let's take the LCM here upon 1. So you need to multiply by 2. So here A only plus 2 multiply, so 2A, and denominator 2 as well, and 180 degree. A plus 2A, that is 3A upon 2 is equal to 180 degree. 2 will go up, 3 will come down. So A is equal to 180 degree into 2 over 3. Now 3 ones are 3 60s are, right? So A is equal to 60 into 2, that is 120 degree. So we get the value of A. I told you we need to get the answer in terms of numbers, right? It's given. Find the value of B, right? So value of A we have SD 120 degree. Now see, angle 4 is 120 degree. Now opposite, vertically opposite. Angle 4, what is the vertically opposite angle of 4? That is 2. And what's its value? B. That's what we want to find, right? So let's write vertically opposite angle. Vertically opposite angles. So we can write angle 2 is equal to B is equal to angle 4 is equal to 120. So we can write B is equal to 120 degree, right? We get the value of angle B, that is 120 degree. Very interesting question it is. We were not aware about that how to approach this sum at the start of it, because there are two unknowns and we need to find one of them, right? And that can be only found with the help of the first one. So idea behind this is try to get all the unknown angle at the one vertex if possible. It will be most of the time possible only, right? So bring all the angles at the one vertex. Afterwards use the property, maybe linear pair or vertically opposite angle. In this case 1/2a, and A is a linear pair. So get the value of A. Afterwards we can see that 4 and B is vertically opposite. So this is 120. So value of B will be what? 120. So this is how we find the unknown angles in the given transversal. Let's do one more interesting question. Here also we are going to find the value of some unknown given in this. So in the given figure, AB parallel CD and L is transversal, then calculate the value of X. So AB parallel CD, these two lines are parallel, L is the transversal, and these two angles are given, and we need to find the value of X. So how shall we approach, right? I told you that try to get both of the angles at the one vertex if possible, right? Then how shall we do that? See, this angle is over here, and if I draw the F, right, we can see that this angle and this angle, they are equal, right? Why? Because they are corresponding angle. So let's write here that corresponding angles. Done. Now you can take vertically opposite angle as well here, right? Vertically opposite angle, then IASS, add them up and you will get 180. That can also work out. I'll explain later again. So corresponding angle, let's give some name to this angle. Let's say Z. So I can write Z is equal to 3x plus 35 degree, right? So these two angles are equal. Now if this angle is 3x plus 35, 3x plus 35, and this angle is 2x plus 15, then what shall we do? What kind of pair is it? It is linear pair. So let's apply the concept of the linear pair. Linear pair. Now linear pair add up to what? 180 degree. So let's add them. 3x plus 35 plus this 2x plus 15 is equal to 180. Then 3x and 2x will make 5x plus 35 and 15. So that's 40 and 10, 50. 50 is equal to 180. So let's move further. Let's shift 50 over that side. Linear equation in one variable. 5x is equal to 180 minus 50, because it is positive over here. So 5x is equal to 130. X is equal to 130 degree over 5. 5 ones are here, 2's are 3 0, 6 are. So let's write X is equal to 26. That was this question about. We need to find the value of X. We get the value of X. Right. So what we did over here, that corresponding angles, right? So you can see F over here. So these two angles will be equal. Now these two angles are only one vertex, so they will be linear pair, and linear pair add up to 180. Now see, equation is in the linear equation in one variable only, so we can solve very easily. So this is how we get the value of X. Another way to do this, right, you can take this angle as 3x plus 35. Let me show you how we can get this 3x plus 35, because vertically opposite angle, right? Afterwards, these two angles are IASS, interior angle on seam side. Now they also add up to 180 degree. So again you are going to come at this equation only, right? You come to this equation with the help of corresponding angles or with the help of VOA, vertically opposite angles. You are finally going to get this equation only, right? You add these two angles and get equate to 180 by linear pair or by the IASS, interior angle on same side, in the second case. So this is how we find the value of the missing variable. Let's do one more sum, very interesting. We need to prove some result over here, right? Let's start. So far we were finding the values of unknown or missing angle. Now let's prove some result related to parallel lines. Let's start. If a transversal intersect two parallel lines, then prove that bisectors of alternate interior angles are parallel. Okay. So first of all, we need to take two parallel lines. We have that, and one transversal. That being done, and we need to focus on the alternate interior angle. First of all, let's give a name to it. That's very helpful. So let's start here. A, then B, then C, and D. Let's name it here M, and here N. Let's name this P, and here it is Q. So we are focusing on what kind of angle? First of all, talk about that. We are focusing on the alternate interior angles, right? There are two kinds of alternate angles, either exterior or either interior. Interior means what? Which is between two lines, and we know very well AIA forms what? Z, right? So let's talk about it. So this angle we will talk about. First of all, let's talk about only AIA for a while, right? We are not talking about something else that we need to prove, only AIA. So let's write AIA, alternate interior angle. So we can write angle APQ. Angle APQ is equal to angle CQP. Angle CQP, right? That being done. So these are the alternate interior angle. Done. Now what we need to do? We need to take the bisector. Yes, bisector. So bisector means what? First of all, let's understand the idea of the bisector. Let's say this is one angle. Now of value, let's take 30 degree, right? And this line will be bisector if it's divided into 15 into 15, right? Means dividing into two equal parts. So let's draw just bisector from this P. So this will be something like this, and another from Q. So that is over here, right? So we have drawn the bisector, right? Now let's give name as well here X, and here it is Y. So done. Now AIA, that is angle APQ, and angle CQP, right? Now bisector does what? Very important question. Bisector divides angle into two equal parts. So this angle APQ, if I divide by half, divide by 2, right? If I multiply 1 by 2 on this side, angle APQ, and 1 by 2 on this side, angle CQP, right? So I have divided into half. Now, so this will be what? Half of it. So can I take name angle XPQ? So angle XPQ over here, and here half of this one will be YQP, angle YQP, because this angle APQ is divided into two equal parts, right? One is this one and another is this one. I've taken only inside one because I want to prove these two lines parallel, right? So to prove line parallel, what I will do, I will prove AIA only. So if you take half of these two angles, that will become one this angle and another this one. So these two angles are equal. Means what? See, if you talk about this line XP and QY, right? So this is forming Z only, right? It is forming Z over here. So Z alternate interior angles are equal. So we can write that angle XPQ and angle YQP are AIA, alternate interior angles. So we can write that line XP, let's write XP parallel YQ, right? So this is how we can prove that if we take bisectors of the AIA and we draw a line, so those lines will also be parallel. Let's talk about the extension of this question. Let's say we have transversal again one more time. Let's take the same transversal. This is one line and this is the another one, and we take the transversal, okay, over here, right? And we want to prove this in the context of corresponding angle. Here we proved in the context of AIA, that is alternate interior angle. Here we want to prove for the corresponding angle. So first of all, let's have the angle bisectors. So this is the angle bisector, and so do this, right? We have the two angle bisectors. Let's name the angle 1 here and this angle 2. So we can write that angle 1 is equal to angle 2. The reason behind that is because it is corresponding angle. Done. Now let's give name to this as well, angle 3, and here angle 4, right? Why did I do that? I'll explain in detail. So first of all, as this is about the angle bisector, divide by 2. So divide by 2 over here, divide by 2 over here. So if you divide by 2 over this side, see, this will be what? Angle 3, because, right, divided by 2 complete. If you divide this angle 1 into half, you will be getting angle 3. So angle 3, and here if you divide angle 2 in half, you will be getting angle 4. So angle 3 is equal to angle 4. Now they are also corresponding angle, right? With this line, remember, with this transversal, they are corresponding. So we can write that these lines are also parallel. Same method we need to do it, as this is the case of the angle bisector. Divide by 2 and check that those angles are equal or not, and if they are equal, then we can say by corresponding angle we can say the lines are parallel. Here the context was AIA, alternate interior angle, so we started with AIA, and with the AIA only we prove that this line XP parallel to YQ. So this is how we do these sums related to proving any kind of result with the help of transversal angles.